Fires on ships present extreme danger. Engine room fires are challenging to combat due to the confined space and an abundance of fire triangle elements: heat, fuel, and air. A vessel's crew must maintain the engine room to a high standard, which reduces the risk of fire. When flammable liquids leak, splash, or spray onto an exposed high-temperature surface, they can auto-ignite. The risk of ignition is higher in the areas around hot exhaust manifolds of oil-fired boilers and diesel engines and indicator valves of such machinery. Fuel leaks cause up to 70% of all engine room fires. Solus requires proper insulation of surfaces with temperatures of 220 degrees centigrade and above.
Good morning to each and everyone. This is Group 2 and we are here to discuss on how to prevent engine room fire on board. Engine room fires are often very challenging to deal with due to the constructions of the room and the plentiful supplies of fire triangle element, which is heat, fuel, and oxygen. A major engine room can fire have destructive consequences, and in aftermath is unlikely for a ship to continue under her own power.
The following heat sources are most likely to start a fire in the engine room: hot exhaust pipe, engine surface, bearings of rotating machinery heating up, defunct electrical equipment. Heat sources can also be introduced by human error, for instance by dangerous use of electric tools and welding equipment. Insulation of exhaust pipe is often found to be defective, especially in the vicinity of the diesel engines, where removal of insulation is needed during engine maintenance.
Good day everyone, this is Engine Cadet Galapi. According to reports, up to 70% of all engine room fires appear to have started out by fuel leaks. It is important to have a good maintenance system in order to reduce the risk of oil leaks. For example, an oil leak detection and alarm equipment which is able to detect and warn a possible oil leak in concealed areas. In case of oil leakage in fuel or any flammable system, instant action of permanent nature should be affected. Under no circumstances should be temporary repairs to oil containing pipes or permitted.
Electrical installation will always represent a certain risk of spark and fire, although the risk is reduced by use of quality safety devices and close adherence to valid regulation. When a vessel is delivered from a new building yard, the electrical installation is normally in a good condition, well tested by competent personnel. Thereafter, the authorities' control of electrical installation on board ship is very lax. At the same time, with the continuous reduction of crew number on board, the position of electrician has disappeared.
I am Engine Cadet Diapilo Gmaril, and this is my report. In some cases, ship operators hire specialist fire training companies to provide advanced training on board their ship. Particular attention should be given to the cleanliness of the engine room. First, high standard of cleanliness should be kept at all time, as they are circular for fire prevention. Second, no oils or oily rags should be allowed close to heat sources, such as boilers and the main engine exhaust system. Third, in some ships there is a large collection of used spare parts and items which are nice to have, such as plastic sheet, wooden planks, used paint tins, and etc. being stored in the fire-prone areas. Fourth, All combustible materials should be discarded along with any outdated equipment that may hinder access in a fire situation. Fifth, tank tops and bilges should be cleaned and hosed down frequently.
Ensuring proper maintenance and inspection. Proper maintenance inspection of the engine room is a key element in avoiding serious and possibly life-threatening event. The officers and crew should have their continual attention and check frequently that first, there is no leakage of oil in the engine room. Second, all repairs carried out to oil pipes are permanent. Third, the quick closing valves and fire dampers are in good condition and properly functioning. Fourth, the engine alarm system is properly maintained and operable. Fifth, fixed firefighting installation are properly maintained and armed. 6. All the combustible materials are stored only in designed areas. Next, all connections, electrical installation are in good condition. The automatic closing mechanism of all fire doors within at the boundaries of the engine room are working correctly, and the insulation covering hot surface in good condition. The last, escape rotors are clearly marked by using deck plate arrows and the exit doors are visible. That's all.
So fire is a constant risk at sea, and one of the most things to happen in your sea career is the severe of fire have emerged because of failures to identify potential fire hazards. It is widely accepted that the best fire prevention is a well-trained crew which comprehend all these potential hazards and consequences. In many cases, the general attitude or awareness of the crew may be by tipping point. Thank you.
Everyone, I am Engine Cadet Vivencio G. Amarillo Jr. and I discuss the cause of scavenging fire on board. Scavenge fire can occur when the accumulated oil in the scavenge spaces are ignited by blow. Pass from the combustion space. The oil within the scavenge space is present due to the drainage from the piston ring area and should flow out of the engine under constant blow down into a drain tank. Normally, no blow blast should be present, but when excess liner and ring wear is present, this called occur. Scavenge fires can cause distortions of diaphragm sealing the scavenge space from the crankcase as well as failure of sealing in that area. In addition, that high temperatures can lead to crankcase explosion as oil droplets are evaporated within the crankcase.
What is scavenge fire? For any fire to occur, we need three elements to make the fire triangle. The three important elements are: first, the oxygen. This is available plenty in the scavenge space. Second, heat source. This could happen because of blowing by of the gases between piston rings and liner or as a result of any rubbing between two surfaces. Third is the fuel. This can be from unburned fuel, carbon, or cylinder lubricating oil leaked into the space. Good day, sir. Good day, classmates. I'm Engine Cadet Dave Rusilier Inglesa. This day, I will discuss about the causes of scavenge fire. There are many reasons for scavenging fire. However, the main reasons are: first, the excessive wear of the liner. The cylinder liner wear due to corrosion is caused due to the reason burning of heavy fuel in the combustion space. This happens because heavy fuel oil contains high sulfur content. During combustion, acids are formed inside the space which should be neutralized by cylinder oil, which is alkaline in nature. And the second, the piston rings might be worn out or have loose ring grooves. A ring groove is recessed area located around the perimeter of the piston that is used to retain a piston ring. Ring lands are the two parallel surfaces of the ring groove which function as the sealing surface for the piston ring. A piston ring is an expandable split is used to provide a seal between a piston and the cylinder wall. Piston rings are commonly made from cast iron. Cast iron retains the integrity of its original space under heat, load, and other dynamic forces. Piston rings seal the combustion chamber, conduct heat the piston of the cylinder wall, and return oil to the crankshaft. Piston ring size and configuration vary depending on the engine design and cylinder material. And the third, broken piston rings or rings seized in the grooves. Piston seizure will only occur when metal-to-metal contact between piston rings to liner exists. Thermal expansion and or lubrication are the primary causes of seizure. And the fourth one, the dirty scavenge space. Scavenge space is the dirty inside the space in the two-stroke diesel engines, which is used for the scavenge air, including the space below the piston, the air supplied by the auxiliary blowers or the turbocharger for the combustion comes here first and then goes to the combustion space. And the fifth one, the poor combustion due to lacking fuel valves or improper timing. It is an intake valve in the open position of fuel will enter the cylinder where it will leak past the rings and eventually mix the engine oil. Oil thinning can be lead to engine bearing damage and scratched cylinder sidewalls. That's the cause of the poor combustion due to leaking fuel valves or improper timing. And the last one, the sixth one, insufficient or excessive cylinder lubrication. As the lack of oil affects the entire surface of the cylinder, there are often seizure marks on both pressure side and anti-thrust side in the piston. In many cases, even in the early stages. And those are the reason for scavenging fire. That's all, sir. Thank you.
Good day, sir. This is Engine Cadet Dorog. My topic is action in scavenge fire in the event of scavenging fire occurring. 1. Contact the bridge and request to slow down immediately and stop engine as soon as possible. Number 2. Contact chief engineer. 3. Stop engine and shut off the fuel supply to engine. And number 4. Stop the auxiliary blowers. Number 5. Operate the steam or CO2 extinguishing medium on the affected cylinders. The last part is engage and operate turning gear with a pre-lubrication. That's all, sir.